Hello everyone. Today I will be working on numerical integration and we'll be solving some problems together. If you like and enjoy my content, you can like and subscribe. And now let's get started. All right, guys. So when we're starting, what I suggest to do is make a table. So these numbers 0, 1, 2, 3, 4 will represent your subintervals. So if you have 4 subintervals, do that until 4. And let's jot down this. And over here, I have to have 0 and 2 as my bounds of integration. And for the inner numbers, I actually don't know what they are. So what I can do is find your delta x. Delta x means your increment. Usually in physics or mathematics, delta x could be referred as an increment, as delta means that. Anyway, delta x in this problem should be b minus a over n. And b being your upper interval and a being your lower interval, and n is a number of subintervals. So for delta x, you will have 2 over 4, which is equal to 1/2. So this means that my intervals should increase by 1/2 every single time. So I will have 1/2, 1, and 3/2. And for the midpoint rule, I'm just gonna erase this. For my midpoint rule, I'm just going to add these numbers, get the midpoint of these numbers. And how do I achieve to do that? I add 0 plus 1/2 and divide it by 2. So you will get 1 over 4. Over here, you will get 3 over 4. And over here, you will get 5 over 4. And over here, you will get 7 over 4. Also, these increments should be accordingly to your delta x. And delta x, let's just write that down, is 1/2. And this delta x will help us with all of our rules we're going to use. So we got our midpoints. So now what I have to do in order to solve this integral by midpoint rule is delta x times all of your subintervals. And I'm just going to say delta x equals 1/2. So you know that this 1/2 comes from delta x. 1/2 times f of 1/4 plus, this is all in the same parentheses, by the way, f of 3/4 plus f of 5/4 plus f of 7/4. Just like that. And I'll just calculate this answer and come up, because you can only calculate this. There's nothing else, nothing tricky in this part. You just plug these values inside the integral function, not the integral function, just the function over here, which is this function 2x cubed plus x. You plug these numbers in, you add them together and divide it by 2. And as an answer, I got 9.75 for midpoint rule. All right, so now let's just calculate the error. Let's estimate the upper bound of the error. All right, then now let's calculate the upper bound of error for midpoint rule. And my answer was 9.75 for the midpoint rule. And now we're going to use this formula. So m, which is being f double prime of max, times b minus a cubed. So that will be 2 minus 0 cubed over 24 times n squared, and that n squared will be 4 squared. All right. And for the answer, we will get we will get 8 over 16 times 24 times f double prime. And what is f double prime? Instead of writing that, f double prime, this is my f function, 2x cubed plus x. And taking the first derivative of this, I will get 6x squared plus 1. And taking the second derivative, I will get 12x. And we have to use our max value for this formula. And where will I get my max value for 12x? Obviously, I will get it at x equals 2. Therefore, my my capital M will be 24. So I will just multiply all of this with 24. And over here, I get 1/2, and these 0.4s get rid of it. So I get 1/2 for my error estimate. So instead of moving forward, let's now actually find our EM, our error estimate for midpoint rule. So this 1/2 is the most our error could be. So basically, absolute value of EM must be less than or equal to 1/2, or instead of writing 1/2, let's just say 0.5. 0.5. All right. So what is actually our error for midpoint rule? And in order to find it, I also have my answer. So that's actually very helpful for us. I'm just going to integrate this definite integral, and we're going to have a very convincing, a very accurate answer, and we're going to find our error estimate. So when you want to integrate that, you increase the exponent by 1 and divide by the new exponent. Stuff all you guys know. So it's this x over 4 over 2 plus x squared over 2 evaluated from 0 to 2. X equals 0 to 2. And from here, you will get 16/8. I guess you should get 10. Is that correct? It looks correct. 2 to the 4th, 16/8 plus 4 over 2. Yeah, you get 10 as an answer for your integral. And what we got for the midpoint rule was 9.75. Therefore, my error estimate should be the actual value minus the experimental or whatever value we got over the actual value. And if you multiply by 100, you'll get a percentage for that. So, all right, guys. So for the error estimate, what you have to do is once you get your exact integral answer, you're going to take the absolute value of that, which is 10 minus the other answer you got, which is 9.75, and you get 0.25 as your error. And if you want to get the percentage, you divide this by the actual value, which is 10 times 100. And since the error we got was less than or equal to 0.5, this is making it logical to be 0.25 because this is less than the actual upper bound estimation of the error. We're actually estimating the error by using these formulas. We're not even getting the actual error. The actual error is the difference between the exact value of the integral and the value you got, whichever way you use. And by doing that, we also have to take the absolute value in order to get a logical answer because you don't have anything like negative error. That's not a thing. All right, guys. So since we have this table over here, what we have to do in order to find our trapezoidal rule is just going to be this formula, delta x over 2. This over 2 comes from the formula of trapezoidal rule times f of the first, which is f of 0. When I'm saying first, this is actually the the subintervals values for the integral. So I will get f of 0 plus f of 2 plus, I'll just explain why I get these, and plus f of 1/2 plus f of 1 plus f of 3/2. All right, so how did I end up with this answer? And this should be inside of parentheses. So basically in trapezoidal rule, because of you're taking trapezoids, the first one and the last one, you're actually multiplying that first number once. But for the other numbers, you're multiplying twice. You're getting those numbers twice because of the geometric shape of the trapezoid. Therefore, this formula is actually coming out to be the first one once, the second one once, and then you're adding everything times 2. All right? And this 1/2 comes out of the formula of trapezoid, and you're multiplying with your delta x, which actually makes a lot of sense if you think it geometrically. If you struggle to find this formula, you can actually draw a simple shape and draw trapezoids, and you can actually create this formula by yourself, which is very exciting, honestly. So calculating this value, I will get, all right, guys, so there's been a mistake of the calculation. So this trapezoidal rule should be 10.5, and you can calculate this by your own. I skipped that part and fortunately asked an AI, and AIs doesn't work most of the time. So the answer for trapezoidal rule will be 10.5 for this problem, this integral. And when we have 10.5, our error estimate actually doesn't change. Therefore, our error estimate for trapezoidal rule should be 1 as an answer. And now, if we want to calculate our actual estimation, we just subtract that from the actual value of the function. The actual value of the function was 10, and this is 10.5. So 10 minus 10.5 in absolute value gives you 0.5 as your actual error estimation. So error trapezoidal is equal to 0.5. All right, guys. So now, last but not least, let's just calculate the Simpson rule of this integral. So of course, Simpson's rule, what we do is delta x over 3 times, first you get the first one, which is f of 0, plus 4 times the second one, f of 1/2, plus 2 of that other one, which is f of 1. I'll keep writing here, plus 4 of f of 3/2, plus 2 of f of, oh, yeah. And now, since we're at the last one, we do f of 2 for 1 time, or 1 times f of 2. So basically, you just go by 1, 4, 2, 4, and go etc. etc. But at the end, you have to end up with 4 and 1. So therefore, the number of subintervals have to be even numbers so that you can end up with, in Simpson's rule, 4, and then you go to 1. And this will be your format for Simpson's rule in this question. All right, guys. So the actual value for Simpson's rule will be 10. And you can just calculate this by plugging all of these numbers in. And now if we move on to the maximum error estimate for Simpson's rule, you will notice that this is actually the exact same number as integrals, that answer, which is 10. And that's only because of this. We're taking the fourth derivative of that function in order to get our maximum error. So if we take the fourth derivative of that, the function, we will end up with, this is the actual function, and you get 6x squared, and then you get 12x as the second derivative, which we use a lot for these functions. And then you will get 12 for the third derivative and 0 for the fourth derivative, as the constant's derivative is 0. And now, since we got 0 for the fourth derivative, you can only say that this Simpson's rule has to be 100% accurate, which means that this formula will generate 0. And if we actually want to see how much error we got, you just do 10 minus 10, and you still get 0% error. That's why Simpson's rule is working the best for every function you can use. This is a very good estimation. And for these functions, midpoint and trapezoidal, you can use them for lower degree polynomials or linear functions or cubic functions. They're going to give you a very low error, especially for polynomials. If we think about that, you're going to get a very less error by using this. And for the first degree functions, you're going to get only 0% error. As if we take the second derivative, let's say I got an integral of 6x, and if you want to do a trapezoidal or the other rule, midpoint rule, you will always get 0, because integrating 6x, you get 6, and the second derivative will give you 0. Therefore, there is not much to do, because you will actually get the same answer of the integral. Thank you all for watching my video. I hope I was able to help you understand the concept. If you have questions or concerns, you're more than welcome to join the comments section and let me know if you want something other than numerical integration or basically integration. I will try my best to help you understand the material. And other than that, have a good day.